Hey everybody, and welcome to how to solve equations with rationals. So if you've watched any of the prior videos, we've done adding and subtracting, we've done multiplying and dividing, all of these with rationals. And now we're going to look at, okay, what if we throw an equal sign in with all of this, right? Because everything that we've done up until this point, if you have watched the previous videos, there's been no equal signs. It's all been rational expressions, right? And we're combining stuff, we're multiplying it, we're dividing it, but at no point did we set anything equal to something else and actually try to solve it, which is what we're going to do here. So the equal sign is going to give us a little more power and a little more leeway, and our tactics and our strategies are going to change a little bit. So how do we solve equations with rational? So first thing you want to check for, because it's going to make your life really easy if it's available to you, is cross multiply. So when you have one rational equal to one rational, you can cross multiply it. Now if you have more than one term on the left or more than one term on the right, this is not available to you. One term on the left, one term on the right. That's it. Alright, then you can cross multiply and solve. We'll see some examples of that. Otherwise, what we need to do is we need to find the LCD of all the denominators. Alright, we've done that before. And then we're going to multiply every term in the equation by the LCD. What that's going to do is that's going to eliminate all the rational terms. In other words, it's going to like blow out all of our denominators. And then we're just going to solve. We're going to be left with a linear equation, or we're going to be left with a polynomial equation at that point. And then we just solve like we would regularly solve. But then the last thing we got to do, because in the very first video, when we're doing rationals, the intro video, I mentioned rationals have this characteristic that at some points they can be undefined. So we have to make sure that the solutions that we found for our variable are not going to make our equation undefined. So that's the last thing we got to check here. So let's start. So there is not really like an analogous thing for constants, because 3/4 equals 5/6 doesn't really make any sense because they're not equal, right? So we don't really have an equivalency here with just numbers like we were looking at in the last video. The most equivalent thing we have is, hey, when we solve linear equations with fractions, how did we do that? So if we look at this equation, and let's see, looks like bright green, looks like fun today. So what are we looking for? So cross multiplication is not available to us because there's two terms on the left, one term on the right. Not going to work here. All right. We'll find the LCD of all the denominators. Well, one denominator is 3. The other denominator is 4. The LCD is here is going to be 12. So what I'm going to do with that 12 is I'm going to multiply it. I'm going to multiply everything by 12. And by when I say 12, I mean 12 over 1. Alright, when I do that, notice what happens to my terms. 12 over 3. 12 divided by 3 is 4. That's a 4 over there if you can see it. 12 over 4, that's going to cancel out to a 3. And then 7 times 12, that's going to give me 84. So now let's rewrite this thing. So 12 kind of blew out the 3, so I have 4 times 1 times x, so that's 4x, minus, everything got blown out, then I have 3 times x on the top, and then 7 times 12, which is 84, equals 84, 4x minus 3x is x, so in this case I get x is equal to 84. Is this answer okay to have? Yes, because in this particular equation, this is just a simple linear equation. In this equation, x is not in the denominator, so I don't need to check if values are going to cause it to be undefined. This is just 1/3 times x, like regular numerator x. So x being 84, totally fine. There's no undefineds actually here. This is a polynomial. Okay, let's apply that to something else. Okay, now I do have a cross multiplication situation. Maybe a different color, black. Right, I have a 1 ratio or proportion equal 1 ratio or proportion, or 1 rational equal 1 rational. So in this case, I can cross multiply. So I cross multiply that diagonal, and that gives me 5 times x plus 1. And then I multiply across on this diagonal. That gives me 6 times x minus 6. Alright, now I solve. Alright, 5x plus 5 equals 6x. 6 times negative 6, negative 36. 6x, let's minus 5x on both sides. And we're just playing algebra. X minus 36. Now let's add 36 on both sides. 41 on the left, x on the right, and we're done. Now, is 41 an okay value to have? Well, the same situation as in the last problem, I have no variables in the denominator, so actually every value is fine. The only issue that we have is when you do have a variable in the denominator, that's when you got to check, because you got to make sure that what you're subbing in to your variable doesn't cause a 0 in the denominator. And if it does, you got to eliminate it. And if you do eliminate it and you end up eliminating all your solutions, then this rational equation actually didn't have any solutions. So if you go through your list of solutions and none of them work because they're all creating zeros in the denominator, at that point you have a no solution situation. And that would just be answered. It just isn't a solution. So let's see another example. Alright, let's solve this. And now we're getting into the territory where we have some variables in the denominator. So step 1, LCD. I can't cross multiply, right? Because I got 2 terms on the left and 1 term on the right. Not going to work. LCD. So I have 6, I have x, and I have 6x. So my LCD in this case, the factor here will be 2 and 3, the factor here will be x, the factor here will be 2, 3, and x. In this case, 6x will be my LCD. Now I'm going to take 6x and I'm going to multiply it by every term. Okay, so number 2 is 6x gets multiplied, so multiply by LCD, everything. So I'm going to multiply 6x here, I'm going to multiply 6x here, and I'm going to multiply 6x here, parentheses. Okay. Now, why? Why am I doing this? Because, let's look. Let's see what's going to happen. 6 over 6. That is not a good enough color. We'll just go with black. 6 over 6. Goodbye. Notice my denominator is gone now. 6x over x. X takes care of x. Goodbye. 6x over 6x. The whole thing cancels out. And notice all my denominators are gone. Okay, I've eliminated or I've cleared the fractions is what we can say too. Alright, what was left over? An x survived and a negative 7. What else is left over? 6 and x plus 1. So plus 6x plus 6. I just distributed it out. Equals, and it looks like just 1. Equals 1. Alright, let's do some algebra. Negative 7x plus 6x, it's negative x. Plus 6 equals 1, subtract 6, negative x equals negative 5. Well, if negative x equals negative 5, then positive x would equal positive 5. Alright, now we need to check. Let me erase some of my madness over here. We need to check. Does x equaling 5 cause a problem for us? Let's see. Well, that's a number, that's fine. Can I put 5 in here? Yes. Does it make my denominator 0? No, it makes my denominator 5, which is fine. When I put 5 in here, what happens? It makes my denominator 30. Also totally fine. Any number is fine as long as it's not 0. As soon as I put that value in there and it makes a 0, then that's bad. Then we got to take that solution, we got to chuck it because it's no good. And then if that's our only solution, then the answer to our equation would just be no solution. Alright, so you always got to check because you can't sub in anything that could possibly make our denominator 0. It will cause a singularity, which in turn will cause a black hole, and it's just all bad. Alright, let's do this one. And I'll use my black again. So again, no cross multiplication, right? 2 terms on the left, 1 term on the right. Cross multiplication is just not available to us here. So LCD, let's see, remember, this guy's over 1, okay, so I do have a denominator there. So I have a 1, and I have an x plus 1, and I have an x plus 1. Hey, my LCD is probably the only denominator that's there, which is x plus 1. The next step, multiply everything by the LCD. So multiply by LCD, and everybody gets an x plus 1. You get an x plus 1. You get an x plus 1. And you get an x plus 1. Alright. And 4, cancel denominators. X plus 1 times x. So there is no denominator here to cancel because it is 1 and anything written over 1 is itself. So we don't need to worry about this too much. So this is going to be x squared plus x. Okay. Minus x plus 1 takes care of the x plus 1. So 2 survives. Alright. Equals. Again here, x plus 1 takes care of the x plus 1. So 2x survives on the right. Oh, look. We're in a quadratic. So minus 2x minus 2x. So we got x squared, x minus 2x is negative x, minus 2 equals 0. We need to solve this. So two numbers that multiply to negative 2 that add to negative 1, this will factor. So you got factoring, you have graphing, and you have quadratic formula at your disposal. Here, we're just solving a quadratic. So solve a quadratic whatever way you're most comfortable with solving a quadratic. I'm going to use factoring in this case because it factors really nice. This is going to factor really nice to x minus 2, x plus 1. Right? Negative 2 times positive 1 will give me the negative 2, and negative 2 plus 1 will give me the negative 1 here. Alright, so then my solutions in this case are, if my factor is x minus 2, then my solution is x equals 2. If my factor is x plus 1, then my solution is x equals negative 1. Alright, so this is what I think we have. Now let's check it, because you always got to check. Alright, and let me, again, erase all the things I've done over here so we can check a little easier. So if x equals 2, is that okay? Well, 2 plus 1 is 3. That's fine. Remember, I don't care what it is as long as it's not 0. Alright, 2 plus 1, 3. Great, 2 works. So we're going to keep the 2. What about negative 1? What happens when I put negative 1 here? Negative 1 plus 1, what happens? What is negative 1 plus 1? When I sub in negative 1, I get negative 1 plus 1. Oh no. Right? We get a 0. That's bad. So what do I have to do? Because this solution caused a 0 in my denominator, what I have to do, I can't use it. I can't use that one. It causes a 0 in the denominator. So our final answer is just going to be the solution to this rational equation is simply x equals 2. Even though we found two solutions, one caused a 0 in the denominator when plugged back into the equation. That's no good. Okay, so I have to throw that answer out, which I did. So therefore, our only reasonable answer here is going to be x equals 2. You always have to check. Alright, so let's review. So when you see a rational equation, first thing to look for, can I cross multiply? Is that available? Do I have one rational equal to one rational? Can I cross multiply? If yes, do it because it makes your life really easy. If not, then we need to find the LCD of all the denominators, and if you need a review on that, go back to find the LCD video, right? Once we have the LCD, our next step here is to multiply every term in the equation by the LCD. And as we saw, what happens when we do that is it actually blows out all the denominators, right? And we're left with something that we know how to solve, a linear, a quadratic, a polynomial equation. It's something we've seen before, it's something we know how to handle, and it's something that we can solve. We can find the solution for it. So that eliminates all the rational terms, and then we solve. And the last thing, which is super, super, super important, we got to check to make sure all the values of x make sense. Because if any of them you plug in and you cause a 0 in the denominator, you've got to throw it out. If you don't, like I said, you're going to cause a singularity. There's going to be a black hole. The universe as we know it is going to collapse. So you've got to check your equations. So thank you guys for watching this video all the way to the end. I hope you guys enjoyed it. I hope you guys had as much fun as I did. And if you guys have any further questions, please don't hesitate to ask.